All right, everyone, we're going to start going over the kind of like the real last big part assignment here, the Behemoth roller coaster analysis. Now, there are two different files that I posted. There is the diagram, which you guys can look at, and then there is the actual paper, which you guys are going to be filling out. So this is a roller coaster that happens to be up in Canada in their theme park called Canada's Wonderland. This was built in 2008. It goes over a mile long. It is over a mile-long ride. You ride this ride for a total of 3 minutes and 10 seconds. They can have 1,545 rides per hour. And the mass of each car happens to have a mass of 500 kilograms, and there's 8 per car. Now, on the diagram, at different locations, there are different things that we happen to know about the roller coaster. Like the height is 70, initial velocity here is 0 at the top of the first hill. At location B, at the bottom of this hill, it has a height of 1 meter. Comes back up to this hill at point C, has a height of 45 meters. Goes down this hill, and as it's coming around this particular turn, is moving at 28 meters per second. So they're giving us a velocity instead. Comes back around where at the bottom of this hill, it's moving 37 meters per second. Comes back up this hill. At this height, it's 35. At this point of the coaster, we got a height of 15. H, we're moving at 26 meters per second. I, 3 meters is our height. 25 meters here at location J. And at location K, we're moving 32 meters per second. And all of our equations happen to be down here in the lower left-hand corner. If we're going to find our total energy, that is made up of our gravitational potential plus our kinetic. GPE is m times g times h, and kinetic energy is 1/2 mv squared. Or remember, 2, instead of 1 divided by 2, you can put in 0.5. So what exactly are we going to be doing with this diagram? So we are going to be analyzing the roller coaster, where we can figure out how much energy the coaster has at each point, and we're going to add a little extra piece where we're finding the velocity, or maybe we're solving for the height. This is going to be broken down into multiple days, where multiple days you guys will have in order to complete this. I'm going to make the first page here, we're going to go over together. Then you guys will have the second page in order for the remainder. So if we happen to take a look here at the top, I included that the mass of the train that contains all the riders, it has a mass of 4,000. G we use as 10 meters per second squared, and all of our other equations happen to be up here at the top. If I'm trying to find GPE, I can take the total energy, subtract the kinetic. If I want to find the kinetic, I take the total energy and I subtract the GPE. To calculate GPE, I take m times g times h, where I'm using g is 10 meters per second squared, and the kinetic energy is 1/2 mv squared. I'll go over this equation and this one here as we get to them, but that is how we figure out how fast it's moving or how high the roller coaster happens to be. So as we take a look here at point A, I'm going to switch over so I can write on the screen, but at location A, not only is it giving us velocity, but it's also giving us the height. When I know height, I find the GPE. When I know velocity, that's used to calculate the kinetic. I'm going to use the equations up here at the top of the page. Initially, I want to find out what is the gravitational potential energy of the coaster when it is 70 meters above the ground. GPE is found by taking the mass, multiplying by the acceleration of gravity, and multiplying by the height. Well, what's the mass? The mass was given to us on the paper. The mass for the coaster each time is going to be 4,000 kilograms. So when I'm finding GPE, I'm taking 4,000, multiplying by G, which is 10, and then I'm multiplying by the height, which what's the height? 70. When I multiply those three numbers together, 4,000 times 10 times 70, I end up with 2,800,000 joules. 2,800,000. If I'm finding the kinetic energy, well, the coaster is not moving at this point. 0.5, don't forget your decimal. The mass, 4,000, times 0 squared, because it is the velocity. And anytime that I multiply by 0, 0.5 times 4,000 times 0 squared is just 0. So as I try to find my total energy equals GPE, 2,800,000 joules, plus the kinetic energy, 0. So my total energy then is 2,800,000 joules. As I happen to take a look now at location B, one of the first things that I'm always going to do is I'm going to fill out my total energy. Because if you remember from the previous lesson, the law of conservation of energy states that the total energy in a system remains constant. So if I had 2,800,000 joules of energy at location A, at location B, I have 2,800,000 joules of energy. This is from the law of conservation of energy. And that's going to be the same each time. Now, what information's given to me at location B? At location B, I know the height. If I know the height, I want to calculate first the energy due to height. Which one has H? That is GPE. So if I'm going to find the GPE of the coaster at this point when it has a height of 1 meter, I'm taking mgh. The mass of the coaster will stay the same the entire time. It is 4,000. G we use as 10. And then H is 1. And when you do that calculation, what do you get? Well, it is 4,000 times 10 times 1, which is just going to be 40,000 joules. Now, if the GPE is 40,000 and my total is still 2,800,000, how do I figure out how much is left for kinetic? That equation's right here. I'm going to take my total energy and I'm going to subtract the GPE that I just calculated. So when I type this in, 2,800,000 joules, I'm subtracting 40,000. 2,802 minus 40,000. That's going to give me 2,760,000 joules, and that is the KE. 2,760,000. Now, how do we figure out velocity? Velocity is found with this equation. If you are using the online calculator, so I'm taking the square root of the kinetic energy divided by 0.5 times the mass. Well, I want to take the square root of what's the kinetic energy at this point? It's 2,760,000 over 0.5 times the mass of 4,000. Now, little trick when you're doing this. Coming over to the calculator in Google. If you do have a regular calculator, that's fine to use, but I'm going to press the square root button. Notice that it starts a parenthesis. Everything is underneath that square root symbol. So I need to put everything under that square root and then close my parenthesis. I want the kinetic energy. which was 2,760,000 joules, divided by 0.5, divided by the mass. Oops, where's the backspace? Okay. Close your parenthesis, equals 31.7. That's my answer. Again, square root button, the kinetic energy, which was 2,760,123, divided by the 1/2, which is 0.5, divided by 4,000, close your parenthesis, equals, again, 31.7. And that's what I'm going to put over here in the velocity box. Wait, I say 31.7? 37.1 is my velocity. And that concludes points A and B and the rest of this video.